Cities today face a glaring contradiction. As extreme heat bakes our concrete environments, local reservoirs are rapidly drying up, leaving millions without fresh water. The strain on global water resources is intensifying. Rapid demographic shifts, volatile climates, and degraded traditional aquifers severely threaten the water security of major metropolitan areas worldwide. Yet, as cities scramble for supply, their own infrastructure is leaking. Up to 50. We need to audit the invisible water flowing beneath our streets and floating in our skies. The first place to look is right at the street level, where the built environment creates the urban heat island effect. The urban heat island effect, or UHI, is a phenomenon where human-made infrastructure absorbs and traps heat, raising local temperatures significantly above natural landscapes. This thermal data map compares a dark red heat dome trapped over a dense geometric city grid with the cooler blue and green signatures of the surrounding land. Dense concrete and tall structures absorb solar radiation and block airflow, causing highly developed areas to burn up to 20 degrees Fahrenheit hotter than nearby vegetated zones. All of this intense localized heat directly impacts the local water cycle. It aggressively evaporates the remaining surface water in city lakes and reservoirs. The hotter the streets get, the more we run our air conditioners to cope. Projections show that by 2050, the demand for residential cooling will surge by 91%. Our surface architecture traps us in a vicious feedback loop. We burn massive energy for cooling, which pumps waste heat outside, accelerating the city's overall drought. The damage from that heat doesn't stop at the pavement. It penetrates deep underground, stressing the aging pipe networks that transport our water. This cross-section diagram of a city street shows how treated drinking water hemorrhages from undetected leaks. Experts call this non-revenue water, or NRW, meaning up to half the water produced bleeds into the soil and never reaches a home. Extreme surface heat bakes the ground, causing the soil to shift and crack. These geological movements physically rupture the brittle subterranean pipes, making the hemorrhage even worse. Water utilities can actively plug these hidden leaks using digital network pressure management and smart metering systems. These digital tools analyze flow rates in real time, pinpointing the exact locations of pipe failures so repair crews can act immediately. Fixing these failing networks is highly effective. Capturing the millions of gallons currently lost to the dirt offers the exact same yield as discovering a massive physical reservoir beneath our feet. Once the underground leaks are sealed, we can look up to the humid air surrounding our high-density residential towers to find our next water source. The Earth's atmosphere holds an estimated 12,800 trillion liters of suspended water vapor. It is a massive, continuously replenishing resource floating directly over our heads. This schematic illustrates the psychrometrics of a standard air conditioning unit, the study of gas-vapor mixtures. Here, warm, humid air hits freezing evaporator coils, forcing moisture to change from vapor into a steady stream of condensate. Zooming out to a massive apartment complex, that single stream multiplies by the thousands. A standard 3-ton residential AC unit reliably generates over 8 liters of water per hour. Across an entire high-rise, that is a continuous flow of thousands of liters of water every single day. There is a deep thermodynamic irony at play here. As severe heat domes raise urban temperatures and trap humidity, they actually increase the specific humidity gradients. This raises the physical capacity for these systems to extract even more water from the air. High-density housing acts as a giant thermal battery, absorbing heat, but it is also inadvertently functioning as a highly efficient, decentralized atmospheric water mine. For over a century, cities relied on a centralized model of pumping surface water from distant dams. That infrastructure is failing, requiring a shift toward decentralized, localized water reclamation. We can retrofit existing residential buildings to capture, store, and distribute their own AC condensate, turning every smart home into an independent micro-reservoir. Instead of dumping it into the sewer, this high-quality, soft water can directly irrigate urban gardens, feed rooftop vegetation, and support facility maintenance. Using this reclaimed water to cultivate greenery and cool the immediate surroundings creates a tangible energy benefit. It lowers the building's own cooling energy requirements by up to 31%. By sealing the ruptured pipes below ground and harvesting the thick humidity in the sky, we change the function of our buildings. The modern apartment transforms from a passive drain on municipal resources into a self-sustaining engine of urban climate resilience.